Hi, 8th grade, Mr. Pastel here. Gonna guide you through Amplify Science Natural Selection 1.5, but I'm gonna start with a video in 1.2, which is an earlier lesson that we skipped. I'm gonna start with a video. What is this kid running from? Is he being chased by something?
Sean?
Over here. Finally, it's down here.
And you're sure this time?
Hurry up, take a picture before it gets away. What did I tell you? A poisonous newt.
This doesn't prove anything. It doesn't even look poisonous.
But I read about this guy that died from eating one, and this looks just like it. His friends dared him.
That's horrible, but I doubt this is the same kind.
Let's go back and ask those rangers if you don't believe me.
All right. Race ya.
Seriously?
Whoa, is everything okay, guys?
There aren't any poisonous newts in this park, are there?
What? We just found one, and we took a picture. Show her.
Yep, that's a rough-skinned newt, and they are poisonous.
Well, poisonous to bugs, maybe, but he's trying to tell me that these are the type that can kill people. Is that true?
Rough-skinned newts have dangerous poison all over their skin, and it is true people have died from eating them.
See, I told you. I read about a guy that ate a rough-skinned newt, and he was all dizzy, and his body went fully numb, and he was dead in 20 minutes.
Unfortunately, that really happened.
We were just a couple feet away from one. We're lucky to be alive.
Oh, you weren't in any real danger. Rough-skinned newts are very shy. Just don't bother them, and they won't bother you.
Plus, there's a difference between poison and venom. Venom is delivered through the fangs. Poison is just if you eat it, you have a problem.
So, are you like a newt expert?
Well, sort of. I'm a wildlife biologist here at the park, and we're researching the rough-skinned newts.
Why are they so poisonous?
A lot of visitors have the same question, and so far we have some interesting clues. We know that the newt population has changed over time. There are more individuals with very high levels of poison now than there were in the past.
These newts have gotten more poisonous over time?
That's right.
I wonder how they got so poisonous.
Excellent question. That's one of the things we're trying to find out. Actually, if you guys don't mind, could you show me where you found that newt?
Yeah.
Sure. Why do you want to see the place?
So I can mark it on our map and we can return there to make observations.
Cool.
The reason we watched that is because there's a question about it in 1.5. So let's go to the warm-up of 1.5. So we have new evidence about a population of rough-skinned newts. We have organized this data into two histograms, one showing the population 50 generations ago. I don't know how often newts reproduce, and one showing the population today. So 50 generations ago, this is the histogram. As we can see, we have a lot of more low poison levels, and today we have higher poison levels. And also what you should notice is that 50 generations ago there were no snakes, but today there are snakes. So possibly an invasive species situation affecting these newts. So the first warm-up question is, which description matches the histogram of the population 50 years ago? So we're looking at this one. So make your choice here. And the second question, which description matches the histogram of the population today? So look at this histogram here. And last question, how has the population changed between this and this? Not too difficult of a warm-up, that's why we call it a warm-up. So let's move on to the simulation. In the simulation today, we're going to test camouflage. So we're going to make the australopes yellow. The australopes, remember, are kind of like the ostrich antelopes. They're the herbivores, basically. They're the primary consumers. So if we make them yellow, Will that always be an adaptive trait in a yellow environment? Whenever you see something with the word always, you should be skeptical. That means that in every case, it will always be adaptive. This is a big hint for test questions. Do you agree or disagree that yellow will always be an adaptive trait if we make the environment yellow? Agree or disagree? Let's move forward down here. Okay, so let's start loading this up. So we are going to test two things. In the first version, we're going to make the australopes yellow, and we're going to make the surface of the environment yellow, and we're going to include carnithons. But later on today, we're going to not include the carnithons, so we're not going to include the predators. We're going to see how much it changes over 50 generations, just like yesterday. We're going to analyze, we're going to get a before-after histogram. So let's do that. Open the natural selection simulation and open the mode camouflage. Okay, so now under biotic factors, carnithons, make sure carnithons is selected. But first we're going to select camouflage. Well, I know that we have to change this to yellow. You change it to yellow all the way, right? Yellow level 7. Oh. Not level 10, level 7. Make sure carnithons are included. Yes, we are including carnithons. Did we have to change anything about the australope? Let's see. No. So I'm going to, oh, it says do not change the initial australope distribution. So I'm just going to run this. Let's speed it up. I'm going to let that run. Oh. There are 2 questions you have to ask, actually more than 2. 3 questions you have to answer here. Which australopes were more likely to survive and become more common? Which australopes were less likely to survive and become less common? The evidence that my partner and I observed either supports or refutes the claim. The claim that they're talking about is up here. Is yellow always an adaptive trait? That's the claim. And then explain what happened to the populations in both environments and why that supports or refutes the claim that yellow color is always an adaptive trait. In this third little bubble right here, we're going to test the same thing, but without carnithons. So if I go here, I'm still going to move this slider to 7. Make sure I'm in camouflage mode. I'm going to turn carnithons off. This stays the same. And we're going to run it. Speed it up. And we're going to get 50 generations on this as well. And we have the same questions, actually. Which australopes were more likely to survive and less likely to survive. This might change. This is a second piece of evidence, which might be different from the first piece of evidence. Remember, the claim is yellow color is always an adaptive trait. So you could have one case where it refutes and one case where it supports, or they could be the same. And explain what happened to the populations and why that supports or refutes the claim. let's move forward. Now these modeling tools, we have the worksheets, which you can find in the lesson brief. It's right here. Modeling tool water storage. And this is asking us to make a prediction about the thorn palm. So we have a new situation here. Predict how and why higher levels of water storage can become more common in a thorn palm population. So it's asking basically, how can we control natural selection in order to increase the water storage in thorn palms? You'll see in the beginning for thorn palms, there's a pretty good distribution, but the water storage is at a pretty low level on average. The question is, they're asking, how can you get a histogram that is higher up on this water storage scale? So actually in this part, I just want you to write your prediction about how could we change the environment so that thorn palms would increase their water storage over many generations. So let me finish this. What would be required in the environment for the water storage distribution to go up? Then in the last part, which I do want you to do, even though it says homework, is to actually put this in the simulation, and they give instructions for that. So I'm going to open the simulation, go to thorn palm water storage. Under abiotic factors, make the changes to the rainfall level that you think will make high water storage traits become more common. So whatever you said for your prediction, you should do it in here. You can change an abiotic factor, like a non-living factor. Don't change this. Let's see. Yeah, change the abiotic storage. I don't think you should change the thorn palm water storage distribution. Well, you can experiment with it if you want, but upload your evidence and what environmental change did you make that caused thorn palms to store more water, and did it actually change the way you predicted? Why or why not? So something you can think about is deserts, like a cactus obviously has increased water storage. You can think of camels that we talked about in class. So basically the assignment for today is to watch that video, which was in my video, and to run through basically everything here. Stay safe out there, guys.